Hi, I'm Dan Cortopassi. Welcome to Layout Building. In this episode, I'm going to continue work on our N-scale Siren Creek project layout. Our N-scale Siren Creek layout is designed to be small enough that Nichole and I can take it with us when we travel in our RV. It's also a way for me to do some model railroading while I'm waiting for the train room for my future HO scale layout to be completed. Using the ties I put down in the last episode, this time I'm going to put down the track on the tunnel side of the layout, including both gauge separations. Because most of the turnouts and track work have custom geometries, and because of all the dual gauge, I'm going to hand lay the track. I have some micro-engineering weathered Code 40 rail that I'm going to use for the hand-laid track. Code 40 rail is 040 inches tall and is much closer to true scale for N than the Code 70 or 80 rail that's used in most commercial track. I also bought several packages of micro-engineering Code 40 rail joiners. I'll also be using some small gauge wire for soldering feeder wires to the track. I'll be using several 3-point track gauges. This is an N-scale Code 40 track gauge from Railcraft. I believe similar gauges are now available from Microengineering. The one in the middle is a multi-gauge 3-point track gauge. I've had it so long that I don't remember who made it. Finally, I have an N and N3 gauge. I don't remember where this one came from either. I've built track by hand before, but never dual gauge. Before I tackle the dual gauge turnouts, I thought it would be good to start with something a little simpler. I'm going to start on the tunnel side and build the gauge separations on the track through the tunnels. A gauge separation is a specialized piece of track that transitions between dual gauge and two separate tracks. It looks similar to a turnout, but it has no moving parts. The narrow gauge always goes through one way and the standard gauge always goes through the other. This image shows how the gauge separation is set up electrically, with the blue and the red representing the two halves of the track circuit. Though it has no moving parts, it still requires an isolated frog to prevent shorts. I will need to gap the rails and cut gaps in the PC board ties in certain places to accomplish all this. I bought Code 40 weathered rail, which actually requires a little more work than non-weathered rail. Before I attempt to solder the rail to the PC board ties, I'll give the base of the rail a light sanding to remove the weathering on the bottom. To put down the rails, I'll be using 3-point gauges. This N standard gauge version has slots on the bottom to fit over the rails, one on one side and two on the other. On top there's a ridge that should be lined up over the track center. This is another reason why I've been careful to align the roadbed to my original track centerline drawings. I'm going to start with the outside rail. The rail away from the camera is temporary and for now is just something to support the other side of my track gauges. I've put a weight on one of the gauges to hold the rail down. I'll solder on the outside of the rail. That way I'll be sure not to get any solder in places that might interfere with the wheel flanges. Once I've soldered a few ties, I'll move the track gauges to a new position. On straight sections like this, I'll solder a few of the PC board ties. Then I can use a straight edge to check the alignment. I can also sight down the rails. When I'm satisfied that it's straight, then I can solder the remaining ties. I'll start the second piece of permanent rail beyond the frog of the gauge separation. I've chosen this spot because there are two PC board ties next to each other. I'll need to gap the rail here, so having the rails soldered on either side of the gap will help to keep them in alignment. Small files are good for removing excess solder on the ends of the PC board ties. The track gauge should glide along the rails fairly easily. If it sticks anywhere, it may be necessary to reheat one of the solder joints to adjust the gauge. When working on a curve, the side of the track gauge with two slots should go on the outside of the curve. This expands the gauge just slightly on curves. Once a pair of rails are down, it never hurts to put a car on the track to test it. This is my oldest surviving piece of rolling stock, first one on the rails on the new layout. Sometimes using more than one gauge is helpful. My Code 40 gauge is my main working gauge. The one farther away is Code 55, a little loose on the Code 40 rail but good enough to hold the rails in rough alignment. The 3-point gauges are also sometimes useful with just one rail. Just like flex track, a rail will form a natural curve when bent. A weight can be used to hold down the end, and then the center ridges on the gauges can be used to position the rail. Soldering one rail in place will make it easier to put in the second one. Gaps on a curve can allow the track to kink. When I get to the end of the rail, I use small files to remove some of the weathering. Then I can slip a rail joiner on the end. Soldering a second piece of rail to the first before bending it and using the rail joiner will ensure that the track maintains a smooth curve. I'll use a file to cut a shallow groove under the area where the rail joiner will go. This will help to avoid a hump in the rail. After also extending the inner rail in the same fashion, I've reached the second gauge separation. I installed some preliminary wiring in episode 5 if you want to see how I set up the underside of the layout. I'm using some 26 gauge wire to solder feeders to the piece of track I just put down. I'll tin the ends of the wires and put a bend in them. Then I solder them to the underside of the rail. Once the track is painted and ballasted, the feeder wires will be very hard to spot. I'll hook them up to the screw terminals underneath. This River Rossi 040 is one of my oldest N-scale locomotives that still runs. I thought I'd give it the first test run on the new layout. It works. I like to test as I go so I can be confident that what I've already done works. When I add a new piece of track, if there's a short or some other problem, it's likely in the section of track that I just built. It's also fun because I get to play with the layout a little while I build it. Now back to business. I need to put in the narrow gauge track. I'm going to start on the end where the drawbridge will eventually go. I'll use my regular N-gauge 3-point track gauge here. This short stretch near the bridge will be the start of the dual gauge. As with the turnout, establishing the geometry is critical. The inside rail will form part of the narrow gauge track through the tunnel. After tack soldering the rail on the end, I'll bend it partway around the curve and tack solder it in a couple more places. The N and N3 3-point gauge that I'm using doesn't have a center mark, so I have to eyeball it. A small piece of scrap rail will support the other side of the gauge and help me to judge the spacing of the rail on the ties. My scale ruler makes a good straight edge to check the alignment of the inner standard gauge path through the gauge separation. The overall geometry of the gauge separation looks pretty good. I decided for this track to cut the rail in the middle of the curve where the alignment is straighter. Later I'll use a rail joiner to splice on a longer piece of rail to finish the curve. I'll use a weight to hold down the far end of the rail and maintain the curve. Then I can solder it to the ties. I'm skipping around and not doing the PC board ties in order. As with the other track, I'm after keeping the natural curve of the rail as much as possible so that the final turn is smooth. Once I'm satisfied with the curve and the placement of the rail, I can go back and solder all of the ties that I skipped. I've cut another piece of rail for the narrow gauge line. This one also ends near the middle of the curve. I'll go down the line with my track gauge and solder the second rail to the PC board ties. I've staggered the gaps in the rail. On curves, I don't like to have gaps on both rails in the same spot if I can help it. I think the stagger helps to keep the track geometry smooth. Just like I did on the standard gauge track, I'm using rail joiners to connect another piece of rail. After I got both rails soldered down, I added some feeder wires like I did on the standard gauge track. The 26 gauge feeder wire that I'm using is too small for the 16 to 22 gauge spade connectors that I have. I found that if I strip the end of the wire, then fold the strands back on themselves, it's thick enough for the spade connector to grab it. If you don't have an abrasive track cleaner bar, or like me, you've misplaced it, a pencil eraser also works to remove the weathering from the tops of the rails. Unfortunately, when I turned on the power this time, my command station indicated a short. The most likely culprits are the PC board ties. These were all pre-gapped, but it's possible that one of the gaps isn't cut through all the way. Starting at one end, I'll use my razor saw to lightly recut each gap. Around the middle of the track, the short cleared. As I'm making this program, I don't yet have a serviceable N and N3 locomotive, so I can't run anything on the narrow gauge. For now, I'll have to content myself with pushing a boxcar to test the track. I noticed that the copper foil on one of my PC board ties came off on one side of the gap. Maybe it got too hot when soldering. This is okay, but it leaves that side of the rail unsupported. I'm going to try cutting out one of the wood ties near it with my hobby knife. Once the old tie is out, I can glue in a new PC board tie. Then I can solder the rails to the new tie. Now that both of the tracks through the tunnel are in, I can start work on the rest of the rails inside the first gauge separation. I'll start by using a couple short lengths of rail to determine the location of the frog. Next, I'll file the side of one rail down to make a sharp point. I'll do the same on the next piece of rail, only on the opposite side. I'm holding one piece of rail in place and using a file to mark the cut line. Then I'll use my flush cutters to cut the rail. Since it's straight, I'm going to tack down the rail on the standard gauge side of the frog first. I'm using the track gauge portion of a Microtrain Z-scale coupler height gauge to check to make sure that the track gauge at the point of the frog on the N and N3 side is correct. I've put a weight on the N and N3 track gauge to hold the rail in place. Now I can tack solder the narrow gauge side of the frog. I'll heat the tip of the frog, letting the solder flow so that it binds the two rails to the PC board ties and to each other. After soldering the rails to the PC board ties, I'll file off the excess solder. I'll also file the frog to make sure it comes to a sharp point. It's important that the frog is electrically isolated. I'm using some scrap styrene to fill the gaps between the rails and gluing them with CA. After the glue dries, I'll cut and file down the excess plastic. I'm using this method because I don't have any insulated rail joiners for code 40, and they would probably be too large for my tastes anyway. Try not to reheat the solder joints in areas that have been glued with CA, as the dried glue releases white smoke when it's heated that can sting your eyes. The location of the electrical gaps around the frog isn't too critical, but they should be placed in such a way as to make it physically impossible for trains on both tracks to be on the frog at the same time. That could cause electrical issues. Or in other words, the gaps should be inside the fouling point of the gauge separation. The fouling point is the place where trains on both tracks will collide. The narrow gauge and the standard gauge boxcars are touching each other well away from the gap, so there's no way that they can both occupy the frog at the same time. To make the rest of the narrow gauge path through the gauge separation, I'll start by putting a couple bends in a piece of rail. The angle should match the frog angle. Since this is the curved leg, I'll coax a slight curve into the rail by running it between my fingers. I'll use a straight edge to check to make sure that the path through the frog is smooth. An NMRA gauge is good to check the flangeway through the frog on the standard gauge side. I've tack soldered the rail in place. I'll use a narrow gauge boxcar to check the track. It goes through without any issues. Even though I've made sure that the flangeway matches the NMRA standard, I want to check it. I'm using an old 1970s vintage N-scale truck with pizza cutter flanges to check it. I figure if this old truck works, then more modern equipment will too. After soldering the rail down permanently, I'll check it one more time with a narrow gauge boxcar. It rolls through easily. I don't feel the wheels dropping down through the frog either, which is good. I realized that I didn't make a spot where I could conveniently cut a gap on the other side of the frog, so I replaced a couple of the wooden ties with PC board ties. I'll solder the rail to the new ties. Then I can use my motor tool to cut a gap in the rail. This one is wider than the gaps I made on the other side of the frog, so I'll need to use a thicker piece of plastic to fill the space. I'll secure it with CA. After it's dried, I can file away the excess. I've cut another piece of rail and bent the end to complete the frog and build the standard gauge path through the gauge separation. This time I'm going to cut it before I install it. I'll use a straight edge to help position the cut rail. Then I'll solder it. My old test truck rolls through without trouble. It took some trial and error to make this last piece of rail. It's tapered on the side that faces the diverging narrow gauge rail. It has to be set to the proper gauge and the opening has to match the NMRA flangeway standard. The frog gaps on this side should ideally be close to the frog, but where the rails are far enough apart so that there's no possibility that a wheel can cause a short. The last step is to install some guardrails. I'll make them from short lengths of rail. I bend each end slightly with pliers and then file a slope onto the side of the railhead. This will help to guide the wheels into the guardrail. This guardrail prevents the standard gauge wheels from trying to take the narrow gauge path through the gauge separation. The other two guardrails are like those of a conventional turnout, preventing wheels from taking the wrong way through the frog and derailing. All of the guardrails are set using the NMRA gauge. One thing to remember is that when building track to NMRA standards, it's not very tolerant of out-of-gauge wheel sets. A lot of commercial track is built to a sloppier standard to accommodate equipment that's made to a sloppier standard. This is one of the reasons that I'm so fussy about things like wheel gauge and coupler height for equipment and track gauge and flangeway standards for track. It all boils down to having the trains operate as trouble-free as possible. I'll use a pair of cars to test each path. I find this is sometimes a better test than just rolling one car, as the second car is being pulled and pushed only by the coupler just like it would be in a train. So far, nothing is derailing. Despite this, whenever I put any track down, whether it's hand-laid or commercial, I expect that there will be a tweaking period as I start to operate the layout. I may need to do some filing here, or adjust the position of a guardrail there to get things as close to derailment-free as possible. For now, though, this looks good. Electrically, the shorter lengths of rail in the gauge separation are powered by the PC board ties that connect them to the adjacent rails. Ideally, I'd like to have a wire on each piece of rail, but that can get a little impractical at this scale with so many short lengths of rail in such a small area. Building the second gauge separation is basically the same as the first. The main differences are that the narrow gauge exits on the right instead of on the left and the track is curved. To make construction a little easier on curves, sometimes I coax a bend into the rail first. This is the completed gauge separation on the depot side of the layout. For now, I've left the dual gauge portion unfinished on purpose. I want to make sure that I don't extend the rails too far in case they interfere with the dual gauge turnout near the depot site that I'll build later. The last step is to wire up the frogs. Because of the way they're gapped, the frog area is too long to leave it unpowered. I always power my frogs anyway. Even in larger scales, it helps to prevent stalling. First, I'll use a multimeter to test for resistance to make sure that the frog is truly isolated from the rest of the track. By my own convention, I like to use white wire to power frogs. I'll solder the wire to the track. Due to space constraints here, I'm soldering the wire from the inside of the rail. I generally prefer to do it from the outside just in case there's any excess solder that might interfere with wheel flanges. Under the table, I'll attach each wire to one of the terminals on one of the frog juicers. These will power the frogs and automatically adjust the polarity as needed. For wiring frogs, it doesn't matter which terminals on the frog juicers are used. When wiring a layout, neatness counts. Cable ties are your friend. All that's left now is to test it out. I'm using my Bachmann 280 for starters. It's working and there are no shorts or dead spots, so the frog juicer is doing its job. The engine does lurch a little on the gauge separations, but that's because its drivers are slightly narrow in gauge. This is an Intermountain SD40-2. This isn't the type of power that I plan on running on the layout, but the wheels are correctly gauged. This one works fine. That's a good place to leave things for now. Next time I'll continue to extend the main line, including the dual gauge turnout near the future side of the depot. I'm happy with the way things are turning out on this layout so far. I'm having a lot of fun with it. Stay tuned and thanks for watching.